Hello, in this lesson we're going to talk about some topics related to circular motion and do an exercise applying this knowledge. So before we talk about the motion itself, let's remember the concept of rotation angle. So the rotation angle is the ratio of the arc length of the radius of curvature. So if we see here in point A, between point A and B, we have this length, the arc length, okay, and the radius of this curvature. So the rotation angle is exactly this relation, this length here divided by the radius. And well, we know that for a complete revolution, this length here is actually 2 pi times r, the radius. So the rotation angle would be 2 pi. And that's the concept of the radians. These are things that we use a lot when dealing with angles and circular motion. So 2 pi radians is actually 1 revolution. That's 360 degrees. Another thing, now talking about the motion itself, that we have is the angular velocity. So the angular velocity is the rate of change of an angle. So it's the rotation angle, the change of angle, divided by time, okay? So the angular velocity, you should know this, is analogous to the linear velocity. And the relationship is this one. So we have that the linear velocity is the variation in space divided by time. So this variation in space, if you think about the circle, is actually this change in angle times the radius, okay? So if you take a look here, the angular velocity is this thing right here. So the linear velocity is actually the radius times the angular velocity. Something interesting that we notice from this relation is that if you have like a disk like this and a particle that's here, another one that's here at the on the edge, we know by this relation that the linear velocity of this particle here at the edge of the disk that's rotating is actually greater than this one because of the radius. The radius here is greater than the radius in the inner particle. Also, if we have something here right here in the center, it's not moving at all because the radius is actually 0. When you talk about velocity, it's really reasonable to talk about acceleration now. And in a circular motion, we have something that's called the centripetal acceleration. And that's an acceleration that points directly toward the center of rotation. So imagine this scenario here. We have a particle that's doing this circular motion, and between B and C we have 2 velocities, okay? It can be the same module, but remember, velocity is actually a vector. So if you see the difference between the 2 velocities here, B and C, we have a resultant that's pointing this direction. So we have this velocity here, we actually have an acceleration that's pointing toward the center, and that's the centripetal acceleration. That's what keeps the particle here in the circular motion. And to calculate the centripetal acceleration, we use this formula, which is the linear velocity squared over r, or r times the angular velocity squared. Now let's practice a little bit using the concept we've just seen. We want to calculate the velocity of a car that has a 0.3 meters radius car tire that's spinning at an angular velocity of 50 radians per second. So what is the centripetal acceleration at the tire rim also? Okay, so we want the velocity of the car and the centripetal acceleration at the tire rim. Well, that's a representation of the problem. We have the tire here, it has a radius, and it's moving at a constant velocity. Okay, that's the same velocity of the car. So because of this, we can calculate the velocity of the car by the velocity of the tire rim, because it should be the same. Okay, so the velocity is actually the radius times the angular velocity. We have the radius, the angular velocity, so the velocity of the car is 15 meters per second. So note that we're calculating the velocity of the car itself by the tire, okay, the rotation of the tire. They are equal because, well, in order for the car to move in a certain velocity, this part of the tire rim, should be also moving at the same velocity. Now for the centripetal acceleration, we have the linear velocity now and the radius. You can just apply it in the formula. And we have a centripetal acceleration of 750 meters per second squared. And that's actually how we calculate the velocity of a car, and that's the information you see in your car panel. Okay, this velocity here is actually calculated using this method. You have the radius of the tire, okay, and how fast it's spinning, right? We have this angular velocity here. So by doing this simple calculation, the car itself, let's say, calculate its own velocity. Hope you enjoy it.
Now that you've learned the theory, it's time to put that to practice. Check out our next videos for practical problems.